Ready?
Let's do it.
Okay. Okay, so right now we're going to do a question. In a flask, hydrogen gas and iodine gas make hydroiodic acid gas. Initially, there is no hydroiodic acid, and then it says the hydrogen gas and iodine gas are 0.0200 molarity each, and the K equilibrium is 9.00. So the first step we're going to do is we're going to make a equation, right? So we have hydrogen gas and iodine gas. So that's going to be H2 gas plus I2 gas. Make hydroiodic acid gas. So that's going to look like this. Hydroiodic acid gas. So now, the first thing they did was they gave us the initial state. So what do we have initially? That's going to be our I. So initially there's no HI. So this is 0. Right? And then how much H2 and I2 do we have? 0.0200 molarity each. The each is important because that means both of them are 0.0200.
Does it matter if you balance the equation?
Oh, it does have to balance. Good, thank you. So is this balanced?
No.
No. So this is 2. Now it's balanced. Good, thanks. So make sure you have it balanced. And that's going to affect our KEQ. So what's going to happen? This reaction hasn't. Has this reaction occurred yet?
No.
No. So it's like this before the reaction has occurred. Now, what happens when the reaction occurs?
A change.
You're going to get some change. It's going to reach some equilibrium. Does that make sense?
Yeah.
So, and by the way, this is reversible. I should add that too.
What's your reversible reaction?
Huh? So it's going to go both ways. Okay. Now, when it's reaching equilibrium, you have things over here, but you have nothing on this side. So what's going to happen on this side? Are you going to increase hydrogen gas, or are you going to decrease hydrogen gas? Decrease, right? So once this reaction occurs, you're going to decrease hydrogen gas because obviously it has to go that way. Same thing with iodine gas, right? And what's going to increase? Hydroiodic acid is going to increase. Now, let's say we're going to give it that it's going to decrease by amount of x. Okay, this is going to be the change, right? That's what the C is. So we don't know how much it's going to decrease by yet, but let's just say it decreases by x. So if hydrogen decreases by x, doesn't one hydrogen react with one iodine? So if there's an x amount of hydrogen decreasing, how much iodine is decreasing? X amount. So then this would also be minus x. You guys understand that? Now, so what's going to happen to the hydroiodic acid? That's going to increase. By which amount? Well, these two are coming together to form hydroiodic acid. So what's it going to be? Plus what?
2x.
Plus 2x. So our initial state, we had 0.0200, 0.0200, and nothing. Our change was decrease by x, and increase by 2x. Now, what will our equilibrium look like? Well, the equilibrium, wouldn't hydrogen gas start with the initial and then minus x? So what would that look like? 0.0200 minus x. Do you guys see how I did that? What would this one look like? What would iodine gas look like?
Same thing.
Same thing. 0.0200 minus x. And what would hydroiodic acid look like?
Plus 2x.
Plus 2x. So this here is my equilibrium. This is going to be eventually what's going to happen. Now, they've given us a K equilibrium here, right? For which one of these is K equilibrium applied for? Only the equilibrium. K equilibrium, you can't use it for the initial. You can't use it for the change. You can only apply it to the concentrations in K equilibrium. So let's set the general equation for K equilibrium, right? So what are we going to have? What are our products?
2x.
First, let's talk about. No, first we're going to do the atoms, and then we'll type in the numbers. Okay. So what's our product? HI, and it's a 2 coefficient. So what's the exponent? 2. Got it. So it's going to be hydroiodic acid squared. Where did I get the square from? Because the coefficient is 2. Right? And what am I going to put on bottom? Hydrogen gas times iodine gas. So now which number should I plug in?
2x at the top.
Good, the equilibrium numbers,
Yeah.
good. So if I plug in, and by the way, what is the K equivalent? It's 9.0, right? So I can plug that in for K equivalent as well. So 9.0 is going to equal, this is 2x, right? 2x to the power of 2. And then what's hydrogen gas?
0.02.
2.0200 minus x, right? And what's iodine gas?
Same thing.
Same thing. Now, this is the same thing twice, right?
Mhm.
So can I rewrite this as, does everybody understand if I rewrite this squared?
Yeah.
Is that understandable? Now, what's 2x squared? 4x squared. Remember, the 2 goes to this 2 and to the x. So this is going to be 4x squared. We got that? So right now, what do I have? I have 9.00 equals 4x squared over 0.0200 minus x squared. Now we have a bunch of things squared. So what do you think is a good thing to do right now? Square root everything. Right? If you square root this, and square root that, what do we get? What's the square root of 9? 3. What's the square root of 4x squared? 2x. And what is the square root of 0.0200? This just goes away, right? So 0.0200 minus x. What do we do now?
Cross multiply.
Cross multiply. I just put it over 1 and then we can cross multiply. Right? So then what do we have? We have 3 times 0.0200 minus x equals 2x, right? What do we do now? Distribute. Right? So what's 3 times 0.02?
0.06.
So 0.06. So, you got this, Scott?
Yeah, I got it.
0.06 minus 3x equals 2x, right?
Mhm.
And then what do we do?
Add to,
Yeah, so plus 3x, right? I'm going to write it over here, okay? So if we add 3x, it's going to be 0.06 equals 5x.
Divide by 5.
So divide by 5. So what does my x equal?
0.012.
So this is my x. So where do I add the x? Okay, so my x is 0.012. So I go back here, because we've done so much, sometimes you forgot what you're actually doing, right? So my x was the change. So wherever I have x, I can just write 0.012. So this is what? 0.012. This is 0.012. This is going to be 2 times 0.012. So what's 0.0200 minus 0.012? 0.008. If you write 0.012 instead. So what's my N equilibrium of hydrogen gas? 0.008. Make sense? And what's my N equilibrium of iodine? 0.008. And what's my N equilibrium of hydroiodic acid? Now we're going to multiply because it's 2x. So what is that? 0.024. And these are all molar. That's it. We found final concentration of the equilibrium. Cool? Very thorough work.
How was that lesson, Aya?
Okay.
How was that lesson, Liz?
For